Hello everyone. So I'm solving today the earliest and latest rounds where players compete, a 1900 hard lead code question. This is the question which I'm solving today. So what this question defines or means? So first of all, we have given n players that which were participating in a tournament and where there will be face off between the first player and the nth player. If we have players like 1, 2, 3, and 4 and 5, then the first face off will be between 1 and 5th. Then the second face off will be between 2 and 4, and 3 will move to the next round because there is no one to face off with 3. So the next round will be happening between the winners of the every face off and the member or player which is left behind. So this is the problem, and where face off is happening between the players. Like here is also mentioned that as example, if the row consists of players 1, 2, 4, 6, 7, 1, 2, 4, 6, 7. Then the player 1 competes with 7, means this will compete with this will compete with this, and one left which will move to the round number 2. And round 1 is happening between these players. So if a winner from 1 to 7 is 1, and winner from 2 to 6 is 2, and 4 is left also. So the next round will be happening between 1 to 4, and after that this player will compete to each other and this will move to next round. So winner from 1 to 4, if we say 1 is the winner and 2 is moving forward to the next round, then what will happen here is that again round 3 will happen, and in round 3 one competes with 2, and then one winner will be decided. So there we don't have to find the winner of all the rounds. We have to find out what is the target of the problem. We have to find out the round, minimum round required for minimum and maximum round required to face off those two players which are given as example, as we have given example number 1. So if you consider this example, which is n equals to 11, means we have 11 players, and the first player is 2 and the second player is 4, and we have to find out that how many rounds will be taken to complete this, to face off between first and second player which are given. Means face off between second and fourth player will happen in how many minimum rounds and how many maximum rounds. This is the problem. So if we consider this example, which has 11 players in tournament, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have to find out that the second player and the fourth player, when the second and fourth, when they will face off. And there is a rule as given in the problem that the ith player will always face off with the n minus ith, or can say uh, n minus I minus 1. It will depend upon the index we are considering. If we choose a zeroth index, and if we choose like first index, means if you consider from zeroth index, on the basis of that will be happening. Like here also it is given that ith player from the ith player from the front will compete the ith player from the end. That is same. Okay, so let me clarify once again. N equals to 11. So if I equals to 1, then if we are considering the not zeroth index best, so here I if I equals to 1, then it will compete with 11, which is n. And if we consider the zeroth index best, then I equal to 0, then we will be doing n minus I minus 1. So there also it will be 11 minus 0 minus 1, that is 10th, which is a zeroth index best problem. So you can do it in your way, that is your choice. But here in problem we consider the zeroth index best, and so so you got the problem what it is saying. So what we will do here is there is a very great method to do this. We have like bit manipulation to like find out all the permutation. Like if we find all the permutation of given uh, players, then we will find that in how many way, like how we will get to that point that the first player is in the zeroth index and the second player is in the n minus 1th index, that we have to finally get it. So the basic thing here is how we will choose the player, that it will go to the next round or it will be disqualified in this round. It will lose. It is your choice. It is your thinking that which player will go to the next round, and in that manner you have to consider that this player will be winning this round and this will not. So if we consider the example of example number one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So here if you consider face off between 1 and 11, then we will choosing the 11 as here is a as in this example we have given that the possible way to get earlier round number from this uh, to face off between the first player 2 and the second player 4. So we'll not go through all the permutation and find all, because the permutation of 11 will be very much larger. So we will not consider all the permutation as here given the earliest and the latest round number. So we will consider this only. So here we will consider 11 as winner. So one will not go to the next round. So we left with 2, 3, 5, and between 2 to 10, we will consider 2 as winner. So 2 will go to the next round. So if you are getting an intuition, so you will be getting that which player to choose and which player to not choose. So for that, we have only two options: choose for next round or not. To do this, I have told you before that bit manipulation is used here because there is only two options, choose or not choose, which will be implemented into 1 or 0. 0 means not going to the next round, 1 means going to the next round. So here we will use recursion to find out all the probability that if we choose this person to win, then what will happen, and if we choose this person to win, then what will happen. So in this manner, we will be going through that. So I wanted to tell you one thing also, that if I will go through one thing, one concept which is a critical thing, that in this the magic of bit manipulation is here, that you can set any player, you can set any player. If you have 1, 2, 3, 4, 5, you can set any player, 2, let's say, or 4, let's say, any player in people of one time to go to the next round using bit manipulation, because we can, if you consider the bit manipulation, like if you have four members, like if you have four, this is four in bits, and you wanted to set, if you consider four, this is number four, but we have to consider this as the first player, this as second player, this is the third player. So if you consider that, we have to like set this person to go to the, this is the first player, this is the second player, this is the third player. So if we have to save that, this is a zero, it can like this, so it will be like this. So if we have to set this person to go for the next round, so what we'll do is that simply just make sure to uh, or with this number. That's all. If we do that, so left shift of 1 will be 1 is here, like this is 1, and if we left shift that, this will be 2. So after left shifting the 1, we got 2, and if we OR with this number, then what we will get is that uh, we will get this number. So from here, what we got, this is the first player, this is the second player, this is the third player. So what we got here is that the second player got admit, means got permission of ours that it will be going to the next round. So here, using bit manipulation, we using this thing, in just big of 1, we can set any player to going to the next round. This is the beauty of the bit manipulation. So, and this will be using in a very way. And if I am right, another thing is that if we like end with, so let it, so I will, so move to the problem. Don't I'm not going into with the bit manipulation. So this is the beauty of the bit manipulation we can use here. So what we'll do is just use recursion, and every time a array will be there where we will be checking that which players are alive to go to the next round, and that will be a vector. We will use a vector alive, in which we will checking that this person will be going to, this player is going to the next round and this will be not, and this will be a very good thing to do. So so let's consider the first of all, we have n equals to 4, a simple thing. It will be good to uh, find all the permutation or something like that. So we will have a mask thing, masking all the player number 1, player number 2, player number 3, player 4. So in the round 1, we'll consider that all player will be going to compete with each other. So we will consider all as 1 in bits. Then it will go in the next round. In the round number 1, we consider that this will be this and this will be this. Let's consider FP as 1 and SP as 2. Means this player is going to, this player is going to, means we have to find out that player number 1 and player number 2, when they will compete with the minimum rounds and when they will compete at the maximum rounds. So in this manner, we will find out all the permutations of this. For this, what we'll do is that in the first round, all player will be going to compete and play the tournament. And the next round, what we'll do is first check that the first player is in, and also we will do. in a live vector is that we will consider a vector in which the first player is first or not, second, third, and fourth. Always we will update the alive vector with the alive players. In the first round we have all alive, so we will have all the player here. So in this recursive approach, what we'll do is that we will match the first player with the 0th index. We will check it out that we will have an index always in the recursion that will be checking that alive of index is first player or not, and alive of n minus index minus 1 is first player or second player or not, or second player or not. So this will be our approach. So in the, let me do it again. We have all set to 1. We have all alive, everyone, all fours are alive. So what we'll check is that here we have 1, 2, 3, 4, and we have to face off between 1 and 2. So here we have alive at 1, index 1 is 1, and alive at index n minus 1 is 4, but we have to go for the 1 and 2. So what we'll do is first check is this matching with the first player or second player or not, because we have to uh, alive these players 1 and 2 always for every rounds, because if we uh, remove those players from the tournament, then they will not face off in any round further. So we have to keep this player alive. So for that, what we will do is the next, when we do next mask, then in the next mask what we will do is just I told you before that doing OR and left shift with the index will alive that player. So in the next mask we will keep the first player as alive, and if we got the second player, then that player will be also set to alive with that with their indices. So these are the two recursion will be happening according to checking that this first index or the last index is equal to the first player or second player or not. So if there is any first player or second player at this index and this index, then this recursion will be called. And if there is no one there, then we will check with both approach that if we uh, take this person as alive and if we take this person as not alive. So here we are not just unsetting the bit for the player, we are just setting the player, means we are just choosing the player. We are, if we choose player, that is automatically saying that you are not choosing other player. That is what is it. So we will choose we will just only choose a player, and for that we'll just use this thing. And what we have done for now is that we have considered that the first player and the second player, first player and the second player are find out in the first index and the last index. So this recursion will be happening there. But when both are not at the first and the last, so what we'll do is that in this manner, what we'll do is that consider the first player as alive one time, and for that also do this thing, and consider the last player as alive, and then apply all the things. And after all this recursive approach, what we'll do, we cannot traverse the whole array. We don't have to traverse the whole players, because we are doing this the first player and last player, first and last, first and last. So we don't have to traverse all the array. We have to consider half of the array. So after recursive, when we will approach, then we will check every time. This is the base case that the length, the index we are getting is now approaching to the length by 2 or not. We will get that this length is now we got that we are at the mid of the array or the array of the players. Then what we'll do is just we'll update that the minimum of rounds we will updating all the time here in this recursion, and when we will just moving forward then update round with round plus one, and here at the base case we will be updating minimum and maximum of the rounds, and this will be considered here. In the round one we will get all through, then the round two we'll get through this only, in the round three we'll get through this only, and when round 4 will get through this. And this manner with we will just update minimum and maximum rounds. So if we see here, we have given constraint as in will be less than equals to 28, sorry. So 28, and we are just doing all permutations for the numbers. So it will be considered as a 2 to the power n time complexity, which is a very harsh thing. It can go to beyond infinity. So, so for this, what we'll do is store all the permutations which are being used in a DP of one thing is the permutation and one thing is the rounds. So this will be memoizing all the permutation with their rounds, and that will be considered in just whenever we are approaching to the next recursive call, then we will check that this recursion is already happened or not. It will used to memorize that. But here is another thing, another complex thing you are thinking about, that we are approaching to a DP of a permutation and the permutation round. What is this? So means a permutation, we have lots of permutation, 2 to the power n permutations. Why 2 to the power n permutation? Because we are choosing the player first time. We have two things. We are choosing that player or not. So we have two choice. And for how many players? N players. So this is the 2 to the power n complexity. And 2 to the power n space it will cover for all the permutation. That is huge. And for 28, 20 n equal to 28 to the power 28. It will go into millions and millions. So this is not a considerable thing. But here is the twist. We are not considering all the. We are not considering all the permutation. We are just considering the best out of it, you can say. Okay, like we will just do this thing at n equal to 28. At first it will be at like n equal to 28 in the round 1, and round 2 it will be 14, and round 3 it will be 7 and 3, and this manner that will happen. Hence there is only log n space will be covered, and the log n complexity log of 28 is how much it will be? it will be around, if you consider here is 2, 3, 4, 5. About it will be 5. So yeah, I'm right. Uh, if I'm wrong, then just forgive me. Just sorry for that. And if I'm right, then that is correct. So means you can think of that. Like the previously what we are doing is that it is 2 for n permutation, but now I'm getting log n permutation, which is very less. It is very less. So in this manner we can do that, but uh, so I think we should code it out. It is a very big problem and a very hard problem as it is given as a very hard bitwise TP is used. And at the first time, I was not able to implement also. So I'm improving day by day. And if you want to improve also day by day, so read all the articles and the materials available in the internet. Like if I have to tell you that which material you should consider, then you can check it out Hacker Earth algorithm blogs. You can check it out where bitwise DP is involved, mentioned, and other things you can check it out is USCO. It is a great platform, and I'm going to also implement this. It is a very big problem, and giving the whole day for this problem is considerable. So I'm improving also. So you should also improve here. So thank you for watching this video. If you are getting something from this video, then it is my gratefulness that you got something. So thank you for watching this video. See you later.